So students, today we are going to do chapter number 4, that is exploring magnets. Reshma lives in a coastal town of Kerala and is very fond of writing short stories. And her grandmother loves listening to her stories. So now Reshma was writing a new story to share with her grandmother on her 60th birthday. Let us see what was Reshma's story. Her story was based on a ship. The ship used to carry spices from Kerala to trade in the olden days. So in the olden days, children, how trade was done or how goods was transported from one place to the other place with the help of ship. Okay, so Reshma was aware that in those days sailors used to find the direction with the help of stars at night. Okay, but now in her situation, in her story, the sailors got caught in a storm and they were not able to see the skies and stars, and because of which they were having trouble finding the direction. Now here Reshma got stuck. How can she take her story forward? She was thinking and she was not able to think any way for the sailors to find the direction. So now she started searching for this information on the internet. She also searched for it in her school library. And students, do you know what did she get to know? She comes to know that travelers used a device known as magnetic compass for finding directions. So, with the help of the internet and her school library, what new information did she extract? She came to know that there is a device called magnetic compass which the travelers use for finding directions. Now, Reshma has seen pencil boxes with magnets. She has seen purses with magnets, okay, which helps them to keep them close. She has seen a writing board in her school, had a duster with a magnet, but she never looked very carefully at those. And now she's very curious to learn more about magnets and magnetic compasses. Okay, so in this chapter, along with Reshma, we will also learn about magnets and magnetic compasses. So children, in your home, in your daily life, you must have come across magnets in various places. You have your fridge magnets, you have cabinets with magnet open and close, you have your pencil box, which there is a magnet in the pencil box which help them keep closed. There's a phone cover, duster, etc. So these are some common items that have magnets attached to them. Okay, the magnets used by the sailor in the olden days were based on naturally occurring magnets. And what are naturally occurring magnets called? They are called lodestones. Okay, so now we have two informations. Information number one, to find the direction, the travelers, the sailors, they used to use magnetic compass. Now the second information, in olden days there were naturally occurring magnets, and these naturally occurring magnets were also called lodestones. Okay, now later on people found out that magnets can also be made with the help of iron. So with the pieces of iron you can also make a magnet. Nowadays we have magnets made of different materials. The magnets that you find in your school laboratory and those used in the pencil boxes, stickers, toys are all artificial magnets. Okay, so lodestone is an example of a naturally occurring magnet, whereas the magnets which you see in your pencil box, in the stickers, fridge magnets or toys, these are all artificial magnets. Okay, the magnets can be of various shapes. Let us see, figure 4.2 will tell us about the shapes of the magnet. So students, if you see the first one, it looks like a bar, a rectangular bar, and therefore it is called bar magnet. Okay, now the other one is looking like a U. It is in the shape of a U, so it is called U-shaped magnet. Children, do you know U-shaped magnet is also called horseshoe magnet? Horseshoe magnet. Okay, so there is another name for a U-shaped magnet, that is horseshoe magnet. And finally, you see a ring, a magnet in the form of a ring. It is called a ring magnet. So magnets can be of three different shapes: bar magnet, U-shaped magnet, ring magnet. Okay. Now we have an activity 4.1 where we are checking about magnetic and non-magnetic materials. So let us go through this activity. Activity 4.1, we have to collect a few objects made of different materials and also a magnet. So now in your house, just go around and just collect a few objects which are made up of different material and also take one magnet. Okay. Now predict which of the objects will stick to the magnet and write your prediction in a table given over here. Okay. So to know what you will do, you will hold a magnet in your hand and bring it near the pieces of objects one by one. Observe which of the objects stick to the magnet. So here we have a list of objects for you. This is a piece of wood. This is a screw, as you all can see. Okay, it's a small plastic object. It's a clip. Okay, paper clip, wire, a key, sharpener, pins. Okay, uh, okay, we also have this object. Let us see what is the name of that object. Is given? No, it's not given. Looks like a matchstick. Yeah, it's a matchstick box. We have a matchstick also. We have a glass, a scissor, candle, a ruler, a stapler, a pencil, a cloth, and we have a magnet. So what are we going to do? We are going to take this magnet one by one near these objects, okay, and then we will see which of them sticks and which does not stick. Okay, so here in 4.1 we are going to record. So first one is a pencil. Material which the object is made up of, pencils are made up of wood, and now we have to write whether it is attracted by a magnet or not. So children, if an object is made up of a wood, it, what do you think, will it be attracted or not? It will not be attracted. So this is the prediction as told by you, told by me to you. You have to check your observation. Take a pencil and bring it close to the magnet and see what I've told you is correct or not. Okay. Now we have an eraser. Eraser is made up of which material? Rubber. So according to me, if you take a rubber near a magnet, it will not be attracted to a magnet. So again, a no. Okay. Now let us see what else do we have in our list. We have a screw. Okay. So let us take a screw. So if you take a screw, screw is made up of iron. Okay, and then if we bring it near a piece of magnet, what do you see? I think yes, it will be attracted. Okay, so you don't have to trust me, you better check it on your own. All right, now let us take one of these. Let us take a paper clip. Okay, so children, if you take a paper clip, just see paper clip is made up of what? Okay, so nowadays we also have a plastic paper clip. We have paper clips made of iron also. So if you have a plastic paper clip, then in that case it won't be attracted to the magnet. But if that paper clip is made up of iron or any magnetic substance, it will be attracted towards the magnet. Okay, let us see a few others, like suppose the glass, matchstick box, or a cloth. Okay, so if you take a cloth, you know, it's made up of cotton or silk, right? So if you take it, it won't be attracted to the magnet. If you take glass, a drinking glass is made up of glass. So will it be attracted? No. Okay, same way you can collect a number of items, you can write down which material it is made up of, and then you can see first write down your answer whether you think it will be attracted or not, and then see your observation whether it matches with your prediction or not. So this is an activity which you all are going to do. Okay, now, was your prediction correct for all objects? Which material stuck to the magnet? What conclusion can you draw? Now, through this activity, we found out that some of the objects were attracted to the magnets and got stuck to it, while others were not. So, students, remember the materials which are attracted towards the magnet are called magnetic materials. Okay, the metal iron is a magnetic material, so everything which is made up of iron will get attracted to the magnet. Now materials objects made up of nickel and cobalt are also metals, and there are other metals that are also magnetic. Okay, so they will also be attracted towards the magnet. Okay, some of their combinations with other metals are also attracted towards magnet. So the materials which are not attracted towards the magnet are called non-magnetic materials. Okay, and that will include paper, glass, wood, okay, cloth. All these materials are plastic, all these materials are non-magnetic materials. So let us now just recapitulate. What did we study? We came to know that to navigate, the sailors, the travelers, they used to use a device called magnetic compass, right? Then we came to know that there are naturally occurring magnets which are called lodestones. Then we also came to know that there can be man-made magnets also. They are called artificial magnets, and the iron can be magnets can be made with the help of pieces of iron and some other substances also. We also came to know that there are different shapes of magnet existing, that is bar magnet, U-shaped magnet, ring magnet. Okay, and now we learn about the two materials. One is the magnetic material, the other one is a non-magnetic material. Magnetic material are those material which are attracted towards a magnet, like iron, nickel, cobalt, whereas non-magnetic materials are those materials which are not attracted towards a magnet, okay, like wood, glass, plastic, cloth, etc. Okay, so now we are heading towards the, what do we know, the poles of the magnet. So let us start. To understand about the poles of the magnet, we have another activity which is 4.2. So let us investigate this activity. Okay, so spread some iron fillings, very small pieces of iron. What are iron filings? They are small pieces of iron. You have to spread them on a sheet of paper. All right, now place a bar magnet over them. Just put a bar magnet over them. Now tap the paper, give them a tap, and observe carefully what happens to the iron filings. You will see something like this occurring. This is your iron, this is a bar magnet, sorry, this is your magnet. It's a bar magnet with a south pole and a north pole, and you see all the iron filings are stuck to the magnet, with maximum at the poles and very less near the middle of the magnet. So what are we going to observe? We see that maximum iron filings stick near the ends of the bar magnet, as shown in figure 4.4, while a very few iron filings stick at the remaining part of the magnet. Okay, so this is our activity. So with the help of this activity, what did Reshma learn? She came to know that these ends of the magnet are called the two poles of the magnet. Okay, what are the two poles of the magnet? The north pole and the south pole. Okay, most of the iron fillings stick to the poles of a magnet. Okay, it is not possible to obtain a magnet with a single pole. So a magnet with a single pole doesn't exist. if you have a magnet, whether it is a bar magnet or a U-shaped magnet, there will always be two poles, a north pole or a south pole. For example, if I'll show you something like this. Suppose this is a bar magnet. Okay. Now the bar magnet has a north pole and a south pole. Now suppose you said that, ma'am, I'm gonna cut this bar magnet in two halves. So what do? You cut them. When you cut them, you got two small pieces of magnet like this. So again, these magnets will have a north pole and a south pole, a north pole and a south pole. So if a magnet is broken into smaller pieces, north and south poles always exist in pairs. Even the smallest piece of the magnet will have a north pole and a south pole. So students, remember, a single north pole or a single south pole cannot exist. A magnet will always have two poles, that is a south pole and a north pole. Now let us see how a magnet can help us find directions. For that, we have another activity. Okay, so activity 4.3. Let us see what is there in this experiment. What do we need to do here? We have to suspend a bar magnet with a thread. You can see here we have a bar magnet and this is a thread. Okay, we have tied it in the middle. The thread is tied in the middle of the magnet as shown in figure 4.5. Now, what we need to do is we have to balance it horizontal. So we helped these books and we have balanced this hanging magnet in a way that it is exactly in the horizontal direction. Okay, now rotate the magnet gently in the horizontal direction and let it come to rest. Then mark the position corresponding to the ends of the magnet on the ground. As you can see, there's a piece of paper stuck on the ground. So you have to, what you need to do, you have to join these 2 points on the ground with a line. Okay, this line indicates the direction along which the magnet comes to rest. Now again you rotate the magnet by giving a gentle push and then again do a similar thing and just see when the magnet comes to rest, does the magnet rest along the same line or a different line? This is your work which you need to see. Okay, so Reshma, once she did this experiment, now she's thinking, what direction does the line indicate along which the magnet rests? But this magnet is resting in a particular line. What direction does this line indicate? Okay, so if we have noticed the direction where the sun rises or sets, we have an approximate idea of east or west, right? Because we know sun rises in the east and sets in the west. Hence, we can locate the direction along which the magnet rests, right? So students, remember, a freely suspended magnet comes to rest along north-south direction. It will always, as many times as you give the magnet a push, when it comes to rest, you will see they always rest in a particular direction, that is north-south direction. All right. The end of the magnet that points towards the north is the north-seeking pole or the north pole of the magnet. The other end that points towards the south direction is the south-seeking pole or south pole of the magnet. Okay, so a freely suspended magnet, how does it rest, students? They rest in the north-south direction. And why does it rest in the north-south direction? Because Earth itself behaves like a giant magnet. So now we come to know a new information. What is the new information? That our Earth, our very Earth where we stay, it behaves like a giant magnet. All right. So you can repeat this activity with a small iron bar. But if you observe it, it does not always rest in the north-south direction. Why? Because it can rest in any direction. It implies that only magnets rest along the north-south direction. So this is a way you can differentiate between a normal iron bar and a magnetic bar. So if they give you two bars, say suppose both look similar, both looks like a magnet, suppose. Now how do you know which one is a real magnet, which one is not a magnet? What you do, take a thread, perform this experiment, give it a push, let it come to rest. What you will observe, the one which just rest in any direction is not a magnet, but the one which always rests in the north-south direction is a magnet. All right. So this activity provides us with a way to test whether a piece of metal is a magnet or not. Clear? So the property of a freely suspended magnet, what property it is? That it will always rest in the north-south direction. Okay. Now, based on this, a small device is constructed which is called magnetic compass. Okay, this magnetic compass was developed in the olden days for finding directions. It has a magnet in the shape of a needle. So if you have never seen a magnetic compass, you can check it online on Google. You can check it on YouTube. You can also buy a magnetic compass from Amazon and check it for yourself. Okay, so it has a magnet in the shape of a needle which can rotate freely. If you can see figure 4.6, it is the diagram of a magnetic compass. Can you guys see this needle in the middle? Just a second. If you guys can see this needle in the middle, this needle, this is pointing, see, this is south and this is north. So this needle is resting in the north-south direction. Why? It is made up of a compass. Sorry, it's made up of a magnet. All right. So the compass is kept at a place where we wish to know the directions. Okay. After some time, the needle comes to rest. And where does it comes to rest? In the north-south direction. All right. So the compass box is gently rotated. How we use this compass box? You gently rotate the compass box until north and south marked on the dial are aligned with the needle. Now all directions at that place are as indicated on the dial. That means you can also say if it is placed in this way, this is the east, this is the west, this is the northwest, this is the southeast. So with the help of this compass, you can find out other directions as well. Okay. Now we have activity 4.4. Let us see what does this activity tell us about. You have to collect a few materials like a cork piece, iron sewing needle, a permanent bar magnet, a glass bowl and water. Once you're done with it, what you need to do is place the iron sewing needle on a wooden table. Put that on a wooden table. Then keep any one pole of the magnet at one end of the needle. Move the magnet over the needle along its length as shown in figure 4.7e. You see, this is the needle. As you can see, this thin one is the needle. All right. And now you're moving this magnet along the needle from one pole to the other. Okay, from one end to the other end of the needle. So bring the same pole of the magnet you started with to the same end of the sewing needle from which you began. And you have to repeat this process. You have to repeat this process how many times? 30 to 40 times. Okay, so what you're doing? You're taking one pole of the magnet and you are sliding it over from one end of the needle to the other. Then you're again going, this is, anti-clockwise direction, anti-clockwise, one end to the other end, one end to the other end, one end to the other end. You keep on going, and how many times you do that? Like around 40 to 30 to 40 times. Now you bring some iron filings or steel pins near the needle. If the pins or the iron filings get attracted to the needle, that means that the needle has become a magnet. Okay, so you just, with this activity, you turned a magnetic substance, which was an iron needle, into a magnet. All right, now pass this needle through a cork horizontally and float it in a glass or bowl with water. You will see that, and keep the needle up. It should not go down under the water. Now, when the needle will come to rest, you will see that it rests. What happens? Your magnetic compass is ready for use. Note the direction in which either side of the needle points. Rotate the cork gently and wait till it stops rotating. Repeat this few more times. Do the ends of the needle always point in the same direction? Yes, it will, because now it also has turned like a magnet. So it will always point in the magnetic north-south direction. All right. Now, let us talk about attraction and repulsion between magnets. Okay. So students, you must have seen that if just few minutes before we discussed about few substances which are getting attracted to the magnet, few substances which are not getting attracted to the magnet. So the substance which were attracted to the magnet were called magnetic substance. The substance which were not attracted to the magnet were non-magnetic substance. Now let us talk about two magnets. Okay, so when you bring two magnets close to each other, what happens? So you see here we have a magnet in this figure. If you can see figure 4.8, we have the north pole of a magnet here and south pole of a magnet here, and we bring another magnet. When you bring the north pole of another magnet to the south pole of magnet A, you will see they get attracted. Whereas if you bring the south pole of a magnet towards the south pole of another magnet, you will observe a repulsion. By this activity, what do we learn, students? We learn that the like poles repel each other. If you take a south pole towards the south pole, they will always repel. Same way, if you take a north pole and bring the north pole of another magnet close, it will show repulsion. There is a force of repulsion. Whereas if you bring the south pole towards the north pole, they will show attraction. That means opposite poles attract and like poles repel. Okay, so we got a very important information over here. What? That the like poles repel and the unlike poles or the opposite poles of the magnet attract. Okay. Now, let us come to activity 4.6. Now, in this activity, we have to take a magnetic compass and a bar magnet. Place the magnetic compass over the horizontal surface and wait for its needle to come to rest. Now, slowly bring the north pole of the bar magnet close to the north pole of the compass needle. What will you observe? What are you going to observe? The needle will deflect. And why will the needle deflect? Because you're bringing the north pole of the bar magnet towards the north pole of the magnetic compass, which is also made up of magnet. So north pole shows repulsion, because of which the needle will be deflected. All right. And if you bring a south pole near the north pole, you will see that the needle is deflecting towards the magnet, showing attraction. All right. So what do we conclude? We conclude that when the north pole of a bar magnet is brought closer, the north pole of a magnetic compass needle, it moves away. Okay, showing deflection away, repulsion. When the south pole of a magnet is brought closer to the north pole of a compass needle, it moves closer, showing attraction. All right. So we have another activity 4.7, and I'm going to leave this activity for you all to do. We have done a lot of activities in today's class. So figure 4.7, you all have to complete the activity. You have to fill the table 4.2 and share it in the comment section so that I can help you with necessary confusions regarding the chapter. Okay. So let us have some fun with the magnets. So with Reshma, we have learned a lot of stuffs about magnet. All right. So now let us have some fun activities. Okay. So you can try all these fun activities over here. This is magnetic garland. How can we make a magnetic garland? Just bring some pins. You have seen boat pins. Just get some boat pins and take a bar magnet and bring them close together, and you see you will have you will just get a magnetic garland. All the pins will arrange themselves in the form of a garland. Okay, so this is amazing. We can also have an activity which is steel balls in a maze. So just make a maze with the help of some straw. You see, these are straws of different sizes, and inside the straw there are some iron balls. So now what are you going to do? Take a magnet, and with the help of magnet you can take out these iron balls from the cardboard tray, from this maze. All right, why? Because these iron balls, this steel ball, sorry, will always be attracted towards the magnet and will follow the direction of the magnet. You can always have a steel paper clip fallen in a glass of water, and you can take it out. How you can take it out? Just take a bar magnet, and with the help of the bar magnet you can take out this piece of pin from the glass of water. So all these are fun activities, kids. I want you all to try it. There's another one, so you can try them at home and have lots of fun with the magnets, and you will explore many new things about the magnet. And if you have any questions in your mind, please put it down in the comment section so that I can help you solve them. Okay, so here there's a small information given to you that in some magnets the north and south pole are marked as north and south, whereas in some other magnets you will observe that the north pole is indicated by a white dot, and sometimes the north pole of a magnet is painted red and the south pole of a magnet is painted blue, in order to tell you that which pole is the north pole and which one is a south pole. Okay, now children, how we can keep the magnet safe? So there's a way of storing the magnet. The magnet says, store me properly. Keep me in pairs with unlike poles on the same side. Keep a piece of wood in between. Place 2 pieces of soft iron across the ends. Do not hit me or drop me or hammer me. Do not keep me near mobile phones or remote controls. Okay, so here you can see how we have stored 2 magnets, placing them with unlike poles on the same side, with a wood in the middle and soft iron pieces on both the ends. Okay, so that's how we store a magnet. And if you want a magnet to not lose its magnetic properties, we should not heat them, we should not drop them, we should not hammer them. Okay, so that's all for today. In the next video, I'll be talking about the summary of this chapter, and we will be discussing all the question answers in detail. So stay tuned for the next video. Thank you and bye-bye.